All right, so in the Edpuzzle that you just watched, we learned that Kw is equal to the concentration of the hydronium ion multiplied by the concentration of the hydroxide ion. Now remember that H plus is the same thing as H3O plus. And so when we are looking at something like that, we're thinking about H plus. Now in pure water, because one water molecule will dissociate into a hydrogen ion plus a hydroxide ion. Because one of these produces one of these and one of those, we have equal amounts of hydrogen ion and hydroxide ion. However, when you start to add an acid to the, to water, what ends up happening is you increase the concentration of hydrogen ion. Now again, Kw is equal to those two multiplied together, and Kw is a constant, which is 1 times 10 to the negative 14. And so this number right here is unchanging. It does not change. It will stay the same. So when you increase one of these, what will end up happening is you decrease the other one. And so, again, those two multiplied together will always be 1 times 10 to the negative 14. So if one of them increases, the other one must decrease. And the way that happens, really, and you don't need to understand why that happens, but I will explain it. The reason why that happens is because when we have something like this, that is a reversible reaction, what ends up happening is if you increase the hydrogen ion concentration, it is going to more likely react with this to go in the reverse direction. And so that's sort of what is going on there. But again, you don't need to know that detail. All you need to understand is that if you increase one, you're going to decrease the other, and vice versa. If you increase the other one, you're going to decrease the other. So what that means is, if you have a solution where you're increasing the hydrogen ion concentration, you're going to end up with a greater amount of hydronium ion because you are putting more hydronium ion in solution. We did talk about a neutral solution where they are equal to each other, and then a basic solution, what you're doing is you're increasing the hydroxide ion concentration, and because of that you end up decreasing the hydrogen ion concentration, so you end up with more hydroxide. So this actually is how we define acidic solutions. Acidic solutions have a greater amount of hydrogen ion, neutral solutions have equal amounts of hydrogen and hydroxide, and basic solutions have a greater amount of hydroxide. So what we're going to do is we are going to use this equation to help us calculate the concentration of hydrogen and the concentration of hydroxide. So let's go ahead and take a look here. This problem says a student weighs out this many grams of sodium hydroxide, which is a strong base. The fact that it is a strong base just tells us that it will 100% dissociate. And then they add it to distilled water so that the final volume is 1 liter. The first thing we need to do is we need to find the molarity of the sodium hydroxide. And we know we have 0.4 grams of sodium hydroxide. And we're going to go from grams to moles using the molar mass. And the molar mass is about 40. And when you type this into your calculator, you get 0.01 moles of the sodium hydroxide. Now, we take this 0.01 moles of sodium hydroxide and we put it inside of 1 liter. And the molarity equation tells us that if we take our moles and divide it by our liters, that'll give us the molarity. Now, just a quick reminder, whenever you see these brackets like this, that is the same thing as saying the molarity of something. So what we're going to do is plug this into the equation here. So it's 0.01 divided by 1 liter. And this is going to give us 0.01 molar solution of sodium hydroxide. Now, before we can answer number 1, we actually need to answer number 2. And the reason why that is because we are given sodium hydroxide, and we know that this is a strong base, which means it will 100% dissociate in solution into the sodium ion plus the hydroxide ion. And we know that because it 100% dissociates, whatever the concentration of this is going to be the same concentration as that. So because this is a 0.01 molar solution, that means this is a 0.01 molar solution. And this here is the answer to number 2. The concentration of the hydroxide ion, which again, concentration means molarity, is 0.01 molar. Now, let's go ahead and we should be able to answer number 1 now. In the way we're able to answer number 1 is by using the Kw equation, because Kw is equal to the concentration or the molarity of the H3O plus multiplied by the concentration or the molarity of the hydroxide. Kw is 1 times 10 to the negative 14. We are looking for the hydronium ion concentration, and we just calculated the molarity of the hydroxide, which is 0.01. And so all we have to do is solve for the hydronium ion concentration by dividing by 0.01, and then we can get our answer. And when you do that, you end up getting a hydronium ion concentration of 1 times 10 to the negative 12 molar concentration of hydronium ion. Now number 3, there's a couple ways of answering number 3. The first way I'm going to tell you is by looking at the hydronium ion concentration and the hydroxide ion concentration. Remember this right here that we just talked about? If something is acidic, it's going to have a hydronium ion concentration that's greater than the hydroxide ion. If something is basic, that means that it's going to have a hydroxide ion concentration that's greater than the hydronium. In this situation, notice how this is a greater concentration. 0.01 is greater than 1 times 10 to the negative 12. Because we have a greater hydroxide ion concentration, that means that it is basic. Now, the second way of answering this question is using logic. What did we put inside of the solution? We put a strong base in the solution, so it makes sense that it is basic. All right, let's go ahead and go to the next problem here. All right, so this next problem, very similar. This is giving us calcium hydroxide. And it's a strong base, which means it 100% dissociates in solution. Now, a very important fact here is this 2 means that 2 hydroxides will be produced for every one of these. So one of those will produce 2 hydroxides. And so what that means is whatever the concentration is of the calcium hydroxide, which it gives us the concentration right there, that is going to be the concentration of the hydroxide, except for it's the concentration times 2. Because again, whatever the concentration of this is, we're going to have twice as much hydroxide ion. And so all we need to do is multiply that by 2, and we get 3 times 10 to the negative 4, and this is the answer to number 5. So the answer to number 5 is 3 times 10 to the negative 4 molar concentration of hydroxide. Now again, once we know one of these, we can always calculate the other using the Kw equation here, because we know that the hydronium ion concentration multiplied by the hydroxide ion concentration will equal Kw. Kw is 1 times 10 to the negative 14, and that's going to be equal to the hydronium ion concentration. The hydroxide ion concentration is 3 times 10 to the negative 4. And so all we have to do is solve for the hydronium ion concentration and when we do that, we get this expression here. Just type that in our calculator and then we'll get our answer. And what we end up getting is 3.33 times 10 to the negative 11. Now again, is it acidic or basic? Again, there's two ways of answering that. We are putting a base, a strong base, in the solution, so it is going to be basic. The other way of knowing that is by looking at the hydroxide ion concentration compared to the hydronium ion concentration. Whichever one has a greater concentration will tell us if it's acidic or basic. Hydroxide has a greater concentration, so that's how we know it's basic. All right, last one here. Notice how in the first two problems we had to solve for this first. And the reason why we solved for the hydroxide ion concentration first was because we were putting a base in the solution, but in this situation we're putting an acid in the solution, so we're going to solve for the hydronium ion concentration first. And so we know that HNO3 will yield, and it's a strong acid, so it's 100% goes this way, this here. Then we also know that whatever the concentration of this is going to be equal to the concentration of that. Because this has a concentration of 2.5 times 10 to the negative 4, that means this will have a concentration of 2.5 times 10 to the negative 4. And so that is the answer to number 7, which is 2.5 times 10 to the negative 4. Now, again, if we know one of the concentrations, we can always calculate the other in terms of hydroxide and hydronium. So if we know one of these, we can always calculate the other. And in this situation, we do know this one. We know that Kw is 1 times 10 to the negative 14. We know that H3O plus is 2.5 times 10 to the negative 4. And we do not know the hydroxide ion concentration yet. That's what we're solving for. And all we have to do is divide both sides by 2.5 times 10 to the negative 4. And when this happens, you end up with this situation here, where the concentration of the hydroxide is equal to whatever that is. What you end up getting is 4 times 10 to the negative 11. Now again, there's two ways of knowing if it's acidic or basic. If you take a look, there's a greater concentration of hydronium ion. Because there's a greater concentration of hydronium ion, it is acidic. The other way of knowing is what are we putting in the solution? We're putting a strong acid in the solution, so it's going to end up being acidic. And that's all there is to it. This is very, very easy. The thing you want to remember is if you know either of these, you can always calculate the other. And the way that we know these is based off of the concentration of the acid or base that we're putting in. So again, we got this value from this. If we look over here, we did get this value from this because we know that whatever the concentration of the calcium hydroxide is, we're producing twice as much hydroxide. And so again, once you know one, you can always calculate the other. And that's all there is to it.